All right, to finish up this whole chapter, we're going to look at two area formulas. And these are focusing on oblique triangles. When you are in geometry, you learned the area of a right triangle. So that was, and it was on the SAT and stuff like that, okay, the area of a right triangle. And it looked like this. Ooh, that was not so good. Okay, and we had a base, and we had a height, and it had a right corner. And the formula for that, anybody remember back from gym? Okay, area is 1/2 base times height. And if the triangle was tilted a little bit on its side, maybe like this, you could still do 1/2 base times height, but where was the height? It's dropping down, it's called an altitude. The height would come down this way, and the height was there. That's where the right angle was, and that was still area equals 1/2 base times height. So that was back in geometry. Now we have trig, and in trig, we deal with triangles that aren't necessarily right or don't have right angles in them anywhere. And so we need two different formulas in order to do the area of an oblique triangle. So an oblique triangle is one where we have capital A, B, C, etc. So in an oblique triangle, maybe we'll have this and this and this, so it's not a right triangle anymore. You can pick any corner. In the right triangle, you got to pick the right angle corner, but in an oblique triangle, you can pick any one that you want. And the area goes by this formula. You can pick angle A, and if so, then it's going to be 1/2 BC sine A if you pick angle A. If you pick angle A, then you use sides B and C. If you pick angle B, then you would do 1/2 AC sine B. So you would use, if you used angle B, then you just don't use side B, you use the other two sides. Or you could pick angle C. And if you picked angle C, then it would be AB sine C. So any of those will work. It doesn't matter what corner you pick in an oblique triangle. You could pick any one you want. But you'd have to know a corner. So then we need one other formula. What if you don't know a corner? What if all you have is sides and you don't have any of the angles? Okay, then there is one alternate formula. So this is if you don't know any angles. Okay, then you're going to use what's called Heron's formula. Heron was a student of Pythagoras. Pythagoras was his teacher. So he lived in Greece at the same time as Pythagoras, and he came up with a formula for a triangle if you didn't know any of the angles. And here's Heron's formula. Area equals all right, first you have to find S. S is what stands for the semi-perimeter. What's the regular perimeter? Do you guys know what perimeter is, just in general? Add up all the sides. What does the word semi mean when you put it in front of anything? Half. Okay, the word half. And so this is called the semi-perimeter. So first you have to figure out that. So if you only know the sides, then first figure out the semi-perimeter. Okay, that's adding up all the sides and dividing by 2. So it's A plus B plus C divided by 2. That's what the semi-perimeter is. Once you know the semi-perimeter, Then you're going to do S minus A and S minus B and S minus C, so the three different sides. You're going to times all those together. And after you times them all together, you're going to square root it. And that is Huron's formula. Okay, so he came up with that. In one of my master's classes, when I was working on my master's degree, we had to work on proving that. And that took us like a couple weeks to prove it. You just have to know what it is. You don't have to prove any of that. All right, so as long as you know this, and this works when you don't have any corners, when all you have is sides. So let's just do a couple of problems, and I'm going to give you, yeah, Garrett. We have like 8 minutes. Can you wait? Okay. So I'm going to do a couple examples, and we'll just practice the two of those. And you just pick which one based on what you have. All right, so here's our first example. Find the area if A equals 43, B equals 53, C equals 72. All right, so based on what you're given, which of the two formulas will you use? I don't have any angle. I don't have any angles. All I have are sides. So we're going to use Huron's formula. Okay, I have no sides, or excuse me, I have no angles. Okay, so sad face, we have no angles. And so let's figure out the semi-perimeter. So S stands for the semi-perimeter. Just take all three sides and add them up and divide them by the number 2. So take 43 and 53 and 72 and add those all up. That's called the regular perimeter. And then the semi-perimeter, when you divide it by 2, does anybody have that so far? 84. Okay, then Huron's formula starts with the number 84. Then comes 84 minus 43, that's the semi-perimeter minus A. And then it's 84 minus 53, that's the semi-perimeter minus B. And then 84 minus 72. So you'll figure out each of those things. And then you'll throw a square root over all of it, and that is called the area. If you're careful about your parentheses, you can type that whole thing into your calculator in one long line, as long as you put the right parentheses each time. So around each set of numbers, yeah.
With the square root, do we have to find the positive end?
No, area is only positive.
Okay, thank you.
And the reason is that area is measured in square, like square feet, square meters, square miles, square what, and anything squared is always positive. All right, anybody have that? You typed it in all the way across. Samuel, what do you think?
1,131.
Okay, I can confirm that. That is what I got. 1131.887, and those are square units. Okay, whether it's square feet, square miles, square yards, square meters, square centimeters, whatever the problem is, it'll be squared in the units. So that's how you do it if you have no angles. If you have no angles, you'll find the semi-perimeter and you'll use Huron's formula. Any questions on that example? I'll do an example of the other one. Okay, all right, here's an example of the other one. Find area if little b is 112 and little c is 52 and big B is 102. Okay, so if you have this, then you do have one of the angles. And so we'll be using the formula that has B in it. So we'll be using the formula that is, we have angle B. So it'll be 1/2 the sine of angle B, But what will go in front of that after the 1/2 and before the sign of angle B if I have angle B? Which one? AC. Do I have everything I totally need?
No.
What am I missing? Okay, I'm missing A. So I'm going to have to do a little bit of work with the law of sines or cosines first to find what I'm missing. And then I can find the area. So what you'll want to do is just set up like usual, like we have been doing. Okay, we've got 102, and we've got 112, and we've got 52. So your job then is to first find the missing pieces that you need so that you can find the area. So what law would be best in this situation?
See?
Sine. Okay, we're going to use the law of sine. So we'll have 112 over the sine of 102 degrees. That'll be 52 over the sine of C. When you cross multiply and you work on the inverse, I'm going to save you time and just show you. Okay, we've cross multiplied and we've done the inverse. So that'll be 52 cross multiplied to sine 102 divided by 112. I've already worked that out. C turns out to be 27. All right, let's kind of fill in our chart, and we know C to be 27. So now that I know C, could I use a different area formula? Could I choose a different one? Well, let's check. The other area formula is if I used C, what would I need between the 1/2 and the sine C if I used that?
B and
I'd need A and B. Do I still have the pieces that I need?
A. No.
No. Okay. So what should I figure out next of my pieces?
102 plus 27.
Okay, so I want to figure out what A is. A turns out to be 51. Well, now that I have that, could I use the other area formula? So that would be 1/2 and then sine A. What would I need between the 1/2 and the sine A for that one? B and C. Do I have all the pieces that I need? Okay, so now I have B and C, so I'm going to use this one because I have all the parts that I need to make that work. So my area will be 1/2. The B is 112, the C is 52, and the sine is of the number 51 degrees. And you just type that straight into your calculator using parentheses and stuff, and it will tell you exactly what the area turns out to be. Okay, I wrote something down, but I want somebody to confirm it for me. Anybody have something? In degree mode? Okay, that's what I had too. I just want to make sure 2,263. That is again in square units.